fusion screen, and we are machining this really simple part. This is the drive for the air shaft to hook to the bearing plate, which drives the ATC in and out. So this is a standard thread, 5/16 24, and then these are metric threads in here. So it's the only standard thread in this design. So basically you start out as normal, simple facing, and then we do a adaptive. This is a pretty small part, so it's pretty straightforward. Do a contour, clean it up, and then I run a bore. That will be with a 3/16 end mill, and I go all the way through, and we complete a chamfer on this side, and then we go to the other side, and a lot of facing with a finishing pass, and then we do chamfer as well, and a drill to go. That's the tab, excuse me, not a drill. So we tap this to a 5/16 24 thread, and then we move to this setup here. It's going to be a center drill in these two positions, a deep drill, and a chamfer, and then finally a tap. So we run the tap through there. So we'll go out in the shop, and it's, like I said, it's pretty quick, so we'll go through it real fast, and then see you on the next part. Hey everybody, welcome to the shop again. Alright, we're getting down on the amount of parts that can be machined on the Tormach, but we got a couple left, so we're doing some little odd and end stuff here. Right now we're making the mount that the end of the air shaft hooks to, that actually actuates or slides the linear rail bearing, drive assembly, all that kind of stuff, the ATC basically. So it's a small part, pretty simple. I already have the stock already chucked up. I have the face mill ready to go. So basically it's a couple tool changes and we're done. So I'm not really going to record this because we're getting down on the amount of stuff, and I think I have one more item to machine after this, and this should conclude the Tormach stuff. So then we'll go through, I have a few lathe projects to do for this ATC build, and then after that we will basically start building, and then concentrate more on the electronics portion of it, the wiring, etc. So anyways, let me get this machined, and then we'll come back when it's done on this first stage. This is a multi-stage because there's machining, then there is a drill and tap, or a flip over surface again, drill, tap, and then it'll have to be rotated up on the end, and then drill and tap two holes where it mounts. So when we come back, I'll have this first stage done, and then we'll go from there. Alright, voila, it is all done. I had 2 metric M6 threads down at this end here. This was a 5/16 24, that's what the shaft thread is. Chamfered on both sides, so came out really nice. So anyways, that wraps up this part, and we'll move on to the next one. Alright, we're on the next project, and we're doing the shaft keepers. Unfortunately, I didn't record the first halves of machining the shaft keepers, but we'll try to get coverage on the other parts. Anyways, these are the keepers. This one here goes on top of the drive assembly, and it mates up against a thrust bearing. So basically all the weight of the carousel and everything is going to be resting on this keeper here, and then this one would be the bottom keeper, and this goes to the bottom of the shaft and holds the forked disc from being able to fall off, even though it's held on by a hub and a set screw. But this is another measure to make sure that it doesn't fall off if the set screws got loose. So anyways, we got to take the vise off, and we have to put our 3-jaw chuck in place and go ahead and clamp these in position. I could have cut these on the lathe, but hey, I got a CNC machine, so I might as well make them, and they're nothing too special other than keepers. So let me get the 3-jaw chuck set up, and then we'll go from there. All right, we have the 3-jaw chuck on here. This old chuck works great for these little parts. The nice thing about chucks is you don't have to zero it out. You're only zeroing your part for a radial part, and then after that, you know, if you do any chamfers, anything like that, it's on round pieces, so it's great. The hole is just barely big enough to be able to reference that as a 0 point. So now we already have the 2-inch face mill in. We're going to go ahead and cut this down, and then cut some chamfers on there, and then there will be some lathe work afterwards. I don't have a regular flathead screw chamfer. I'm guessing it's a 45 degree. I only have as a 90 degree, so it doesn't cut the correct chamfer for the flathead to recess or countersink into the part. So we'll go ahead and get this machined. The next one, I'm hoping I can do it on this. I may have to get a creative machine on the lathe, a little spacer to hold it up, because there's not very much of a lip on the bottom side to grab with the jaws. So I've reduced the amount of depth per pass really low, so that way, because this is only 3 jaws supporting it, and I don't really want to load it up too much, so I think I'm doing 0.010 of an inch per pass, so it should make quick work of this anyways. Alright, we machined the other one. This one is the bottom keeper, and there was just not enough material on the lip that's on the bottom of it that's to grab in the jaws, but there was plenty on the sides, but I was worried about running the face mill into the jaws. So I happen to have, like, this is like 20 thousandths. It's a plastic sheet. I just cut a hole in it, and then so the part would slide through it, and then that would give me a 20 thousandths off the jaw, because this would be sacrificial plastic. So we'll get this machined up and we'll come back. All right, they are all done, and hold on, we got a little spider friend here. There we go. We have the parts all made. So basically at this point I got to put this on the lathe, and I have a countersunk bit that I can put the countersink in for the M6 flathead screws, and then that makes the keepers done. And I believe that pretty much wraps up a majority of the CNC. We still have some of the steel parts, which is going to be for the mount assembly that mounts to the column, and it's going to have some 2.5-inch square tubing and some steel fittings that actually have to be welded to the 2.5-inch square tubing, and we'll have to get those cammed and machined together. But in the meantime, we're going to wrap this episode up, and then when we come back, we'll work on something next. See ya.